right, hello everyone. This is the day 3 worksheet on polar graphs. I just thought I would talk through my answers. The first one here, I tried to kind of fill in a couple of my work and stuff that I went through on this. So again, like what we've been doing for all of the other equations that we've been graphing, one of the first kind of bets, one of the first nice things you can do on this, really your best bet, is that you can set r equal to 0. So that's why we started consistently doing that. So really what you're doing when you're setting r equal to 0 is, again, you're trying to find out where those places and how many times is it going to intersect that pole, that middle point on the graph there. That can tell you a lot about the graph. So this one, right away, the first thing I thought of is I'm like, okay, there's an A value and a B value. That tells us right away that it's going to be a rose. And because that B value here is odd, from those patterns that we looked at, we know that there are going to be 3 petals. Whenever it's odd, we have that many, whatever B is, that many petals here. So that can kind of help that to keep in your mind as you're going through here. So I set r equal to 0 divided by 4. And then we want to decide where is the cosine equal to 0. That's at pi over 2 and 3 pi over 2. But because this is 3 theta right here, we are actually adjusting our interval to go from 0 to 6 pi. So I had to keep adding 2 pi. So if I added 2 pi to pi over 2, that gives me 5 pi over 2. If I add 2 pi to 3 pi over 2, that gives me 7 pi over 2. We can keep going. So 5 pi over 2 plus 2 pi gives me 9 pi over 2. 7 pi over 2 plus 2 pi gives me 11 pi over 2. So really 11 pi over 2, again, that's 5.5 pi. That is going to be the last one that fits in this interval right here. Divide everything by 3 and we get these 6 answers. This whole part so far, nice thing about that is it's actually really good review from our last unit. That's the exact same stuff that we went through in our last unit. And based off of the last quizzes, those were actually looking pretty decent for those of you that showed the work for it. So again, we know that there's 3 petals along the way. So we need to find out where are those 3 petals. So if you remember from the video, again, finding where it equals 0 doesn't tell us where the petals are specifically. But we know because this is this graph has symmetry to it, we know we can figure out then where those petals would be. So if it crosses through the pole at pi over 2 and pi over 6 right here. If I look at those there, and let me draw it in here for you. Let me get my pen. If I am at pi over 6 is right here, right? And pi over 2 is right there. Again, we want to know what's halfway between there. So halfway between is right here at pi over 3. So that's the pi over 3. So we know we have a petal at pi over 3. But we have to think about where would that petal be. So that's the work I showed over here. If I put pi over 3 back into the original equation, again, the original equation, let me move this, original equation was r equals 4 cosine of 3 theta here. So that means I'm putting that in 3 times pi over 3. And mostly I do this in my head, but I wrote it out here. 3 times pi over 3 gives us pi. Cosine of pi is -1. So 4 times -1, that gives us -4. Again, that brings us, if positive pi over 3 is going in this positive direction. So this is the positive pi over 3 direction. But if we're going -4, that's why it's this blue point right here. Then if I'm going between pi over 2 and 5 pi over 6, so again, pi over 2 and here's 5 pi over 6, halfway between there is this 2 pi over 3. So again, I did my work for 2 pi over 3, that's down here in green. So 3 times the 2 pi over 3, that gives us 2 pi. Cosine of 2 pi is 1. 4 times 1 is just 4. So that's why it's the green point up over here. Okay, then if I'm going between 5 pi over 6 and 7 pi over 6, so 5 pi over 6 is here, 7 pi over 6, I already have those, we are looking at pi. So if I'm looking at pi, again, I plugged that in. The cosine of 3 pi is the same thing as the cosine of 1 pi, which is -1. And 4 times -1 gives us -4. That's why, again, the positive pi axis is going in this direction here. That's where r is positive. But if r is negative, it would go over right here. Now, you'll notice I kind of stopped my work I have my 3 petals. I don't need to do any more work. If you wanted to keep going, obviously you could. If you're going between 7 pi over 6 and 3 pi over 2, right? If I'm looking at those, 4 pi over 3 would be that middle point there. But if I plug in 4 pi over 3, we're going to get positive 4 out of it. And so I get the point right here. And then again, the next one's going to be at 5 pi over 3, but that's going to be negative 2 or negative 4. So it's going to show up over here in green. And then the last one would be 0. But again, I don't need to do that one because it's just going to be a repeat. That's going to be at positive 4 going in that direction there. So again, that's why I just stuck with those first 3 because I knew that those were our only 3 petals there. All right, looking at the next one here, we know that this one is going to be a 4-petal rose. So this is all the same work from our last unit. Where is the sign equal to 0 at 0 and pi, but we're going all the way up to 4 pi, so I added 2 pi and 3 pi onto there. Divide by 2 to get these 4 numbers. So again, this tells us, it doesn't tell us where our petals are, it tells us the zeros, like the where it goes through the pole. So again, if we think about it, if we have one here at 0 and another at pi over 2. Again, that's actually those points are right here at the center. But because of the symmetry that it has, we know that one of our petals is going to be halfway between at pi over 4. So again, if I plug in pi over 4, the sine of 2 times pi over 4, we can write it out even if you want to here. So r equals 6 times the sine of 2 times the pi over 4. So 6 times the sine of that would be pi over 2. We know the sine of pi over 2 is 1, and so that gives us the value of 6. So that's why I have a point right here at positive 6. Halfway between pi over 2 and pi is, I'll change it back, is right here at 3 pi over 4. And again, if I substitute 3 pi over 4 back in, I'm going to get negative, so it's actually coming down to this point right here at the 7 pi over 4. If I do halfway between pi and 3 pi over 2, we're at 5 pi over 4. That's going to be positive 6. We get a point right here. And then again, we have to think this last one we're here at 3 pi over 2 and going back really to 0. That last one is going to be here at 7 pi over 4. If we substitute that in, we get negative 6. So it's going to be actually this point over here. And that gives us our 4 petals. Notice number 3, hopefully this one stood out to you. This one did not have a B value, so we know this one is just a plain old circle. Mine is not a great circle. I should maybe fix it, but it doesn't look like, but it is an actual circle on here. Again, I filled out some of my main points here. You wouldn't have to do all of these on here. The 0, and then we know it's 0, and at pi over 2 it's negative 6. Really the pi and the 3 pi over 2 you definitely wouldn't need. I would say those are just kind of repeats there. But then these help us round out our circle. We know that the sine of pi over 6 and 5 pi over 6, we know that sine is 1/2 right there. So negative 6 times 1/2 would give us negative 3. Again, those give us just some better points to help us round out that circle. Number 4, we know this one's a rose with 3 petals. So once again, the same kind of process. We just want to know where is the sign equal to 0, but we're going all the way up to 6 pi. So I have all my values here. Divide by 3. And again, I'm looking for those middles. I'm looking for the middles on that. So between 0 and pi over 3 would be pi over 6. But again, that would end up being negative 5 right here. And then between pi over 3 and 2 pi over 3 is pi over 2. That ends up being positive 5 when we sub it in. Between 2 pi over 3 and pi would end up being 5 pi over 6. This is the positive, but again, we end up getting a negative value. You could absolutely figure out the rest of them. You wouldn't need to because we know that it's just going to repeat the same petals. All right. Number 5, again, you'll notice these end up all kind of being similar. We know this one is a rose with 4 petals. So we're going between 0 and 4 pi. So I named all the numbers where the cosine would be 0 divided by 2, and again found those halfway points. At pi, again, the colors correspond here. At pi over 2, if we sub in pi over 2, we end up getting into the original equation here, negative 5 cosine 2 theta. We end up getting positive 5 here. If we sub in pi, we end up getting negative 5. That corresponds here. Again, halfway between our 5 pi over 4 and our 7 pi over 4 is 3 pi over 2. We end up getting positive 5. And then halfway between 7 pi over 2 and then really pi over 4 again ends up being this 0. And we end up getting negative 5. So here we know this one is a rose with 3 petals. So again, same thing as, ooh, whoa, sorry. My goodness. There we go. Sorry, guys. We end up getting our 6 values here, but again, we know there's only going to be 3 petals, so I just stuck to the first 3. But again, be really careful with your positives and your negatives. If you sub it in, 3 times pi over 3 would give us pi. We know the cosine of pi is negative 1. So negative 6 times negative 1 gives us positive 6. So we are at pi over 3. You can probably start to figure out the patterns that these are symmetrical. They are kind of evenly spaced out there, and those can help you figure out the rest of them as well. Now, number 7 was a good review of one of our limacons here. When we set r equal to 0, we find that there are 2 points there that it crosses through the pole. That tells us that it's a limacon with an inner loop. Because again, what happens is, if you can see my, let me draw in yellow here. If you can see this as we go through this one, and I'm going to show some of these graphs a little bit more in depth later, but it starts out here and it comes and it crosses through the pole once here, follows the loop and crosses the pole a second time here. So whenever it crosses through those 2 times, when we know it's a limacon here, it's a limacon with an inner loop. So I found my 0, pi over 2, pi, and 3 pi over 2, and then because it's a cosine, I use pi over 3 and 5 pi over 3. Notice I didn't use 2 pi over 3 and 4 pi over 3 because we know that that equaled 0. That just helps us round out the rest of this kind of circular side right here, because we know the cosine of pi over 3 and 5 pi over 3 is 1/2. All right, last one is another rose. This one is a rose with 3 petals. Again, we found our 6 values where it crosses through the pole. Really, when we're looking at these, the domain ends up really being from 0 to pi, so that's why I kind of cut it off here as well. We don't have to do the rest of that work with these because we know there are 3 petals. So check these over. The next couple days I'll post a video that you can kind of watch that will show kind of how these unfold based off of kind of our more rectangular graph, just to kind of give a better idea on there. Okay, let me know if there's questions.